Hello guys, in this video we'll see projection of solids when the axis of the solid is perpendicular to VP and parallel to HP. Okay, this is the continuation video on projection of solids. I already made two videos. I shared the link for those two videos in the description box. If you want, you can make use of it. Okay, so now we'll see how to draw the projections for this following 5 questions in the AutoCAD software. Okay, take the first one. A pentagonal prism of base side 30 mm and axis length 60 mm is resting on HP on one of its rectangular faces with its axis perpendicular to VP and draw its projection. So first we have to identify according to the given condition on which plane you will get the true shape. Okay, so here the axis is perpendicular to VP. Okay, so you will get the true shape on VP. Okay, keep in remember that. So whenever the axis is perpendicular to particular plane, okay, in case of this projection of solids, so you will get the true shape on that plane. Okay, now so the axis is perpendicular to VP, so you will get the true shape on VP. So go to the AutoCAD software. First set the units in millimeters, type units, set it in millimeters. Okay, and you have to set the limits. Okay, we have to define the workspace boundary for the workspace. I'm giving the size of the A3 sheet. Okay, 0, 0 and 420, 297. And then third command is very important, zoom and all. Okay, you have to select all. Now we'll start drawing the projections. Okay, draw a horizontal line. Okay, press F8 and draw this for a random length. Okay, I'm drawing it for 400. Now we have to give the text. Okay, you have to name this line. Okay. Type text and click the start point close to this line and give the text height as 5 mm. Enter. Angle of rotation 0. Enter. Okay, this is here. You can specify the alphabet you want. And above the line it is according to the first. We are dealing only with the first angle of projection. So above the line it is VP. Below the line you have to put it HP. Okay. Now we will draw the true shape on the vertical plane. Okay, the given shape is a pentagonal, a prism. Okay, so you have to draw the prism in such a way that is resting on HP on one of its rectangular faces. Okay, so now I'm going to draw the pentagon. So type polygon, draw the pentagon, type polygon in the command box. And enter the number of sides as 5. So and it is resting on the HP itself. So you have to draw the pentagon in such a way it is resting on the reference line itself. Okay. So start from here. So you have to use the edge option because we don't know the radius of the circle that is inscribed or circumscribed around the polygon. Okay. So edge method. So click on the first point and move to the right and specify the side length as 30 mm. Okay. So it is given in the question that it is resting on the HP. So I have drawn it on the reference plane. It's one of the bases will lie on the reference line itself. Okay. So now you give the names to the corners. Okay. Type text. This is the start point. 5 angle of rotation 0. So A. As it is a prism, okay, you will have a top face as well as the bottom face of similar shape. Okay, so for top face, for the front face, so I'm giving as A, B, C, D, E, whereas for the bottom face, I'm giving as P, Q, R, S, T. Okay, so now this is A. For the bottom face is the hidden corner. Okay, bottom corner is the hidden corner. So I'm putting P. So next one is B, bottom corner Q. The next one is C, bottom corner R. And this one is D, bottom corner S. And then E, bottom is T. Okay. Now what you have to do? Now you have to project lines. Vertical lines up to this reference and then you extend this line for a random length. Okay, this length, how much it should be in front of VP. Okay, that distance is not given in the question, so you can take it randomly. So I'm taking is this 25. So you come up to reference line. From reference line, you take 25. Okay. First come up to reference line. From then you take 25. So you can ensure that all the lines, that is projected lines from this reference line, will have a same length. Okay. Now it is a prism. Okay. So now it is a prism. So we have to draw a rectangle. So the length of the rectangle is 60. The axis length is given in the question, it is 60. And this length we don't know. So what you do? You start, you put a line from this corner for 60 and then you connect the lines. So now when you see from the top, okay, when you see from the top, this edge B, as well as the edge C are hidden edge. Okay, so whereas this top edge ED is a visible edge, so I am going to put a solid line for that. Whereas first draw the line, and then to represent it as a hidden edge, we have to change the line type as a dashed lines. So go on load. Okay, select this type and select the center also. There are 3 types of center lines. You load all the center line as well as one dashed line. Okay. Now select these 2 lines and change it to dashed type. Okay. Because those 2 edges are hidden edges, so we have to represent it in dashed form. Okay, now you specify the alphabets. Okay, type text. This is your start point. So this face is this face corners you have to define A, B, C, D. Okay, this is A, B, E, and this one is C, and this one is D. Okay, and this one is the bottom face, that is behind this other end of the prism. It is P, Q. This one is T. This one is R. This one is yes. Now you have to give the dimension to show the axis length. Okay, so I'm giving this edge length, and to specify the side length, so you have to use the align dimension and you have to specify the side. Okay, and now at the bottom, so after finishing, you have to write all the dimensions are in mm. Okay, at the all dimensions are in mm. Now this is the projection for the question number 1. And now we'll move on to the question number 2. A triangular prism of base side 35 mm and axis length 60 mm has one of its rectangular faces parallel to and 15 mm above HP. Okay, the triangular prism is placed 15 mm above HP, that the parallel faces one of the rectangular faces is parallel to this HP. Okay, all longer edges of prism are perpendicular to VP. Draw its projection. Okay, now the axis is, they are given all longer edges of prism are perpendicular to VP. That means the axis of the solid is perpendicular to VP. That means you will get the true shape on vertical plane. So you have to draw a triangle. The true shape is the triangle. You have to draw it on VP. They are given at it is located 15 mm above HP. Okay, this is 15 mm. Okay, 15 mm above HP. So you have to locate this triangle 15 mm above HP. So first we will mark this 15 mm from this reference line. Okay, 15 mm. Now go to polygon enter the number of sides as 3, select edge method. So now click one corner here and move to the right and specify the length as 35 mm. Okay. Now you connect this corner of the triangle to the reference. So now we have to project lines, okay, from here. Okay, this distance they haven't given this distance, so you can either start from the reference line or else you can assume some distance randomly. So I'm going to assume 15. So from this projected line also I'm going to take 15. So from here I'm going to give the axis length, which is 60 mm. So this side length is 35. Again I'm joining here. Okay. So it is a prism. You will get a rectangular face when you see from the top. Okay. So now from the center also, you have to this edge, from this edge also you have to extend one line. Now we have to give the name. So again go to the text command. This is start point. So one face I'm giving A, B, A. So other face, the same corner is P. This is B, Q, and this one is C. The top one is R. The other side, the hidden side, we give it as R. Okay. Now we have to give the name here also. So whenever we mention the top view, so we'll put a dash. I forgot to put a dash on the alphabets here. So whenever you represent top view, you put a dash over this alphabet. Similarly, for this diagram also, we'll give that we'll define the corners on the front view. Sorry, on the top view. Okay, this is A dash, C dash. This is B dash. Okay, now this is P dash, R dash. This one is Q dash. Now we have given the names to all the corners. Okay, now we will give the dimension. So first one is aligned. First you give the length of the side. This is 35, and then mention using the linear. You mention the length of the edge is 16, and one more dimension they are given in the question. This is 50 mm above HP. Okay, that also you have to show that is 50 mm. Now this is the projection for the second one. Now we'll move on to the third one. Okay, third one they are given an hexagonal pyramid of base 30 mm and axis length 60 mm is resting on HP on one of its sides. Okay, with its base parallel to under 20 mm in front of VP. Okay, this in front of VP, you have to mark it on HP. Okay, this is in front distance. This in front distance you can able to see when you see from the top. So you have to mark it on HP. So first we will identify where we will get the true shape. Okay, the question according to the question given. Okay, the true shape will fall on the vertical plane. That means VP. So first I will draw the true shape. Okay, the true shape here is hexagonal pyramid. So type polygon. Enter 6. select edge method. So they didn't give any they didn't define any distance, how far it is above HP, they didn't define. So you can assume it is resting on HP itself. So they have given, sorry, in the question itself they have given it is resting on HP on one of its sides with its base parallel to HP. So now the side length is 30 mm, and now you project vertical lines from all the corners up to this reference line. Okay, now what we have to do? So now they have given it is 15 mm in front of VP. So from here, since it is a pyramid, you put a line from the center also. So now they have given this 15 mm in front of VP. So mark this 15 mm first. So we'll go and check the question. So it is 20 mm in front of VP. So this line should be 20 mm. Take a line, type 20. So similarly, from all the corners, you will project a line for 20 mm. After projecting 20 mm, you connect end the points of all the projectors. So now it is a pyramid. We have to mark the axis length from the center line. Okay, the length is 60 mm. Okay, after marking this center line, then you have to connect to the corners. So all the corners connect to a common point, this apex. So I connected all the edges. Okay. So when you see from the top, okay, so you can able to see all the edges. Okay, this edge, this one, and this one. Okay, these two bottom edges you can't able to see, but it lies below the edge of these two edges. Okay. So anyway, when we have to represent the top edges, top two edges which are visible, so we have to put it in the continuous line. So there is no hidden lines to represent in the top view. Okay. Okay, this is the center line. So center line, you can change the format to a center line. So one more thing, when it is given as a pyramid, what you have to do, in the true shape, you have to connect the corners to the center. So to differentiate this projected shape from the construction lines, what you do, you increase the thickness of the line, or else you can increase the color also. So I'm going to increase the thickness as well as the color so that I can differentiate the in the top also you can differentiate. Now give the names using the text option. So I'm going to give us A, B, C, D, E, and then F. The center it is O. This point is O dash. This corner is A dash, B dash, and the f dash, this edge is f dash, okay, b dash will come in the bracket. Similarly, e dash, c dash will come in the bracket, and this one is the d dash. Now we have to give the dimension. This axis length, give the axis length, this is 60 mm, and you also mention this in front of distance, which is 20 mm, and you also have to represent this side length. So I am taking this align dimension, representing this side length. Now we will move on to the next one, next question. So I am extending the same reference line. Now we will move on to the question number 4. A cylinder of base diameter 50 mm and axis length 60 mm is resting on HP on one of its generator with its axis perpendicular to VP. Okay, they are given the axis is perpendicular to VP and draw its projections. So now first take a vertical line, draw a vertical line for the 50 mm, okay, or else you can directly, this is a cylinder, okay, so the base shape is a circle, so you can take a circle. So they are given it is resting on HP, okay, so that the one point on the circumference should lie on this reference plane, okay. So it is so for that reason, first we will mark a vertical line for a length that is equal to the radius of the circle. Okay, diameter is given 50 mm, so I am going to give the radius as 25 mm. Now take a circle and take this point as center, and now specify the radius as 20. Now exactly this point is making contact with this reference line, because in the question they are given it is resting on the HP. So at least this one part of the circle has to touch the reference line, okay, according to the condition. Now from here you project up to this reference line, and from that reference line we don't know how much it is in front from the vertical plane, so we will take it randomly. 15 mm is not given in the question, so I am taking it randomly. Again up to this reference line, again from the reference line 15 mm. Center also I am going to draw it for 15. From here I am going to mark the axis length, which is 60 mm, and to the right it is 25, which is equal to the radius of the circle. So I am joining up to here. So as it is a cylinder, you will get the rectangular face. Okay. Take a line. From here I mark it for 60 mm, then connect to this. Okay, since there is no corner in the circle, so you don't want to mention any names to this to the circle. So you give only define this center of the circle. This is O. Other than that, there is no need of giving any names to any of the corners in this top face, this rectangle. And then just mention the dimensions. Okay, this one is 60, and for circle you have to use this diameter option or radius option. Specify it. Now we'll move on to the question number 5. Okay, question number 5 is a cube of side 40 mm is side 40 mm is resting on HP on one of its edges with the face containing the resting edge equally inclined to HP and two vertical faces parallel to VP. So according to the question given, they are given that the cube is resting on one of its edges. Okay, the resting edge is equally inclined to HP. Okay, equally inclined to HP. So we have to draw this in such a way that okay, first we will mark this inclination when it is equally inclined. So we have to mark a line first. So if it is equally inclined, so then it makes an angle of 45 degree. Okay, the one side of this cube is making 45 degree. So I will put a line for a random length, and this angle I am setting it as 45. Now we have to place the cube on this line. So I am again taking this polygon. So enter the number of sides as 4. Select H method. Okay, you start from here. So on the line, we have to go on the line. Okay. So you have to make 40 mm. Then enter. So now this edge, okay, this bottom edge is equally inclined. So this angle, this side also it is 45. So we will check the angle. Okay. This is 45. Similarly, this side also it is 45. That means equally inclined. Now the edge is equally inclined to HP, horizontal plane. So now we don't want this line, excess line. So you can use the trim option. You can trim it. Now extend lines from corners up to the reference plane. So from here we don't know that how much it is in front from this vertical plane. Okay, that distance we don't know. So I'm going to take it randomly. So I'm going to take 20 mm. So 20 mm it is in front of VP. So I am taking this 20 mm randomly. Now you connect this end of the projected lines, and now it is given as a cube. Okay, so from here to extend a line for 40 mm. For cube all the sides are equal. Okay, so here this we don't know what is the distance. So here from this corner also extend a line for 40 mm, and then you connect these two lines, same point of this. From the center also you have to mark a line like this. Okay. Now give the names to all the corners. Okay, text. So this one is top face. I'm going to give A. This B, this A, we have to, within the bracket you have to give A, within the bracket you give P, and this one is B, within the bracket Q, C, Q, R, S, okay, so R, this one is D, within the bracket S. So I'm going to delete this one. So similarly here also, top you also will give the names. Okay, this is the front face. Okay, so this I'm going to give A dash. This one is this. So when you see from the top, you can able to see the D corner. Okay, D dash, whereas B corner is the bottom corner. Okay, so I'm putting it in the bracket, and this one is the C dash. On the other face, it is P dash. Here again, S dash is visible. So S dash. S dash within the bracket Q dash, and here it is R dash. Now give the dimensions, take linear, give this axis length 40, and take align dimension, mention the length of the side of the cube, just 40. So if you want to highlight, if you want to differentiate this projected objects from the construction line, then you can go for increase in line weight as well as the this change in color. So after this, you can So convert to PDF, go to this plot, Microsoft Print to PDF. So window, so select all the objects, center the plot, okay, landscape, check the preview, okay, preview is fine. So it is projection of solids, axis perpendicular to VP. So I will share this PDF in my personal website. So I will share the link in the description box. If you want, you can go and download. Thank you.